Quantum technologies have the potential to really disrupt our society and reshape our economy.
In the Netherlands, we've built over time, over the last 20 years, a research position that is unequaled in the world. For instance, the Delft Institute, QTech, is among the top 3 in the world in this technology area. And that goes for a number of other places. And if you look at that, this is something we should capitalize on.
Quantum technologies are really important. For example, quantum computing allows us to do calculations that are currently impossible. And if you could do those calculations in the future, you could solve things that are now unimaginable, like for example, for medical applications, but also for example, climate calculation and climate models. Quantum networks and quantum communication, which allows unhackable communication, which really means a lot for our safety. And of course, you also have quantum sensing, which makes the tiniest sensors that also could improve medical devices, but also navigation and metrology.
The second thing we do well is to make sure spin-out startups occur. International industry is attracted to these places and grows further. So what we need for the next step in quantum is this fantastic technology that we have developed so well that it takes hold in the industrial environment. The strategic program for quantum focuses at the transfer of technology into industry. The most important hubs for quantum in the Netherlands are present, and that's Delft, Eindhoven, Leiden, Twente and Amsterdam. Working with the whole world, we want the economic value as much as possible to end up in the Netherlands through, for instance, control points that are supported by our projects.
The focus of the innovation domain quantum technologies of Holland high-tech will be mainly the collaboration also between science and industry, which is really important at the moment because for quantum technologies we still need to solve a lot of technological and engineering issues, and therefore you need collaborations between scientists, engineers and companies.
We are improving the process of qubit testing, which is essential for scaling up. There is an ambition on the market to go from hundreds of qubits to thousands of qubits in the next 4 or 5 years. Pace is accelerating dramatically if we look at the roadmaps of large companies. And what we aim to do is to keep up with that pace and align our roadmaps so that our solutions are ready to meet those needs. So far, we've been doing lots of automation, and this is what we will continue doing. Nevertheless, that's not sufficient to meet the needs of proper testing. So we will not only do automation, but also parallelization. And that's a tricky scientific question, which we are going to tackle together with the DiCarlo lab at QTech. The quantum chip is a system very susceptible to noise. So doing things in parallel has many scientific questions to be resolved ahead of how would you do that without destroying the state of another qubit or disturbing the state.
The companies are growing fast. They need capital to grow. The deep tech capital in venture funding is low in Europe. It's getting better, but we still have a challenge to solve that.
Since quantum is still an emerging technology that really needs a long-term horizon, it helps to be embedded also in long-term policy visions. And that is important because it needs long-term funding, it needs stable policy measures, and it also needs to be recognized and connected to other adjacent technology platforms. The innovation domain and Holland high-tech have all kinds of instruments to make, for example, these public-private partnerships possible, and also allow us to enhance these collaborations and also accelerate them.